Greetings and welcome to another lecture in statistics. As a advisory for this chapter in particular, please make sure that you have watched the prior video before you watch this one, simply because everything builds on everything else. It's really kind of complicated. You're going to be doing a lot of writing. I also suggest that you watch this with one finger poised over pause, because the odds are you're going to be stopping to make sure you get everything written down. As with other videos, I'm not going to be pausing to allow people to write things down during the video, because you can pause and watch this as many times as you need to. So what we're dealing with here is an ANOVA, which is also known as the F ratio. Now, I talked in the prior video about the difference between a between groups comparison and a within groups comparison, and that's exactly what we have here. It's a ratio of the between groups number that I'm going to show you how to calculate divided by the within groups number. And so what is going on here essentially is that you want to have the between groups be larger than the within groups, because the larger this ratio, the greater the possibility that we'll reject the null and accept the results as significant. So the more difference there is between groups compared to within, that's what we're looking for. Now, there's a couple of different types of means that we're going to be talking about here. The first one your text calls the group mean, and it's the mean of each individual group. It's also known as the sample mean. Essentially, this is what we've been talking about in a lot of ways in the prior chapters. So using the prior example of different schools, the public schools have a group mean, the home schools have a group mean, and the private school has a group mean. It's just the mean of each of those groups. However, there's also something called the grand mean. Grand mean. What this is you add up all the individual scores and divide by the total number of scores. Okay? Not by the total number of groups, the total number of scores. So you're lumping all of the groups together. Do not add up the averages of each of the means and then divide them. That's not how you find it. Okay? You find this by adding up all the individual scores, dividing by the total number of scores. Now, this grand mean is also, the way the group mean is oftentimes abbreviated as what I call X bar. It's an X with one bar over it. The grand mean is often abbreviated by an X with two bars over it, or as I'm going to call it, probably very clumsily, X bar bar. So this is all the scores divided by the total number of scores. It's like it's the mean of every single case that you have. Not groups, just every single case. So we're looking at the variation here, remember? So in variation, there's two different ways that we can do it. We can either subtract or find out each score's variation from the grand mean. How much does each individual score, each individual case vary from that overall mean? Or we can look at how much each particular score, each particular case varies from its group mean, from the group into which it belongs. And those are the various types of things that we're going to be looking at, that we're going to be doing. When we look at the difference between a score from its group mean, that is within groups, because we're looking at the difference within that one particular group, just that one group. X bar is just that one group. Okay, so that's within groups. On the other hand, if we're looking at the difference between the score and the grand mean, the score and the mean of all of the scores, ignoring groups entirely, that's called between groups. Because we're looking at the difference of each score from the overall mean, not each score from the group mean. That's between, that's including all the groups. A way to think about it with what's going on today might be looking at the difference between at the moment we're having the COVID-19 pandemic, and so there are different rates of positive test scores for both the United States and the states as a whole. There are places online you can actually go and find these. And so there are 50 states. Each state has its own mean, has its own average of positive COVID-19 test results. On the other hand, the country also has everybody in the country, a grand mean, looking at that. So what we could compare here is the difference if we wanted to see whether or not a particular state had a higher or lower rate than the country as a whole. Yeah, then we're probably going to be looking at these same sorts of F ratios. Okay, we're going to look and see whether there is a difference in the variance in one particular group versus another to see whether or not there is a difference. And trust me, there's probably going to be a lot of these done with the studies that are going to be done looking at various medications. Instead of looking at them one by one, they'll probably have a study with lots of different medications to try to treat this and then look to see what happens. So how do we do this? Well, first I'm going to give it to you basically in a sort of step-by-step, and then give you the equations, and then I'm going to give you an example where I do it all in front of you. So you have a chance to look at the overall, how you do it in the abstract, and then look at the, given this example, this is how we do it. So the first things we want to find is the within groups sum of squares. Notice how that is abbreviated by SS sub W. Okay? SS sum of squares, SS sub W, which means within. And so what we're going to do here is pretty similar to what we've been doing. You know, in statistics, everything adds on to everything else. If you remember back when we did sum of squares, when we did those for the first test and we were doing, you know, looking to see, you know, where these scores fall in terms, yeah. So I think that was chapter 3. I don't remember. There's been a lot of chapters. But this is going to look very familiar because it's the same thing. What did we do then? We basically subtracted the mean of the group from each score. We squared the difference and then we added them up. And that's exactly what you're going to do here. You're subtracting the group mean. So the mean for that sample, X bar, from each case within a group. You're going to square that difference because remember, if you don't square it, it'll add up to 0. So you need to square it. And then you add them all up. Okay? So you add up all of these cases from the group means, you square that difference, you add up all of those differences, and there you are. Okay? I guess each case from its group mean is not really necessary, but yeah, it's you know, we're adding up all of the squared differences of each case from their group mean. This is exactly what we were doing before. Now it's between group sum of squares that it gets a little bit different. Okay, that it gets just a little different here, because we need to take into account the fact that the odds are very good that you're not going to have the same number of cases or the same number of samples per group. Okay, that you know, in the US, different states have different populations, different states have different numbers of people who've been tested. A lot more people have been tested in places like New York State at the moment that have been tested, say, in South Dakota. So you're going to have different numbers. And so you have to take that into account. And the way you do that is as follows. Now, here you're not working with individual cases. Here you're working with the group means. So what do? You subtract the grand mean from the group means. We're looking at differences between the groups, not between the cases and the group. That's the within groups. This is between the different groups, how many groups you have, 2, 3, 4, 7, however many you have. So you subtract the grand mean from each group mean, and then you square that, which is pretty much what you're doing with the first one. You're just using slightly different numbers. Square that difference, because again, if you don't square it, you're going to wind up with 0. Now here's where the difference comes in, because you have to weight these scores. If you've got one particular group that has twice as many individuals as the other group, you need to weight the group with twice as many, twice as much than the other group with only one. They're not equal. They have different number of cases. Here's where the cases of the groups come in. So you take that squared deviation, that squared difference, okay, and you multiply it by the number of cases in each group, and then you add them up. You're weighting them. It's the same thing that we do when we weight scores. It's the same thing that I do by hand when I weight different scores for people's grades. You have to multiply them. Usually when I'm doing it for grades, it's by a percentage, but it's the same kind of deal. Here you're multiplying them by the number of cases. and then you add them up. And that will give you the between groups sum of squares, SS sub B. Look at the sub part there. Within versus between, S versus B. What do we do next? We turn them into estimates of variance. Okay? So we're turning these from, we're turning them into estimates because we have standard error and all those other lovely things. And how do you do that? You do that the exact same way that we did it before. You divide each sum of squares, okay, that you found, either sum of square B or SSW, by the appropriate degree of freedom. And again, the degrees of freedom here are probably also going to be different because we have different numbers. So how do you find those? Well, the degree of freedom for B, for between, is abbreviated as dF sub B. Not surprisingly, for within groups, the degree of freedom is dF sub W. So that's how they're abbreviated. How do you find these? Well, basically what you're talking about here is each group is considered a category. So in that prior example, when we had 3 groups, we had homeschooling, we had public school, we had private school. There were 3 groups. Okay? And so K in that case would equal 3. Okay? K equals 3. So how then do you find the degree of freedom? Well, normally you would take n, which is the number of cases minus 1. But in this case, we're using K. Okay? So we're using the number of groups, the number of categories. So the degree of freedom for between is K minus 1. Okay, and that's basically, what we're thinking about in terms of, n minus 1. It's the same kind of thing. We've got 3 individuals or 3 groups. Then the degree of freedom for the between is going to be n minus 1 or k minus 1. But it's within the within that gets a little more complicated because, again, it's looking at something different. It's looking at what's going on within each group. The groups are different sizes, so forth and so on. So the degree of freedom for W, for the within groups, is the total number of cases, which your book calls n subtotal, minus k. To tell you the truth, I'm not entirely sure of how I can explain the logic of that. That just is the way that it is. We're taking the number of groups away from the number of samples, and that is simply how it works. Okay? So once you do that, let's get to the F ratio. Well, first we have mean squares. Mean squares sub B, between, is the estimate of between groups variance. And you find that by taking the sum of squares of B divided by the degrees of freedom of B, for between. Sum of squares B divided by degrees of freedom B. The mean squares for W is the estimate of within group variance. And perhaps not completely surprisingly, it's the same thing as MS sub B, it's just with W's instead of B's. So the different numbers, they're looking at different amount of variance. Okay, this should also look familiar because we've been dividing by degrees of freedom and all in order to get the mean squares between groups. These are different types of variance. And so once you've gone through and found those, the final F formula is rather, simple. You take the mean squares for between groups and divide it by the mean squares for within groups. And that'll give you the F ratio. Now, what we're going to do in the next video is we're actually going to walk through a problem. You may want to sit and look at your notes here for a few minutes to make sure that you understand the steps, or read the text to make sure that you understand the steps before we basically get into an example. And what you might want to do is go through and look at this. This is in your book, Table 10.4, and it goes through all the steps. It doesn't give you the math, but it goes through all the steps that we were looking at before. So make sure you look at all of these, you look at the steps, you understand how they got these, you understand how they put together before we get started on the next video where we're actually going to be doing an example with real numbers.